So let's do the basic things. Those are that we read integer, we can write print on the screen, we can add up and do subtract, multiply, division, and halt, ignore operand, and terminate the machine. So we will learn this, but before starting to do this, let's also know about this LDC. It is like written like this. It's in this form, and what we do, it says place the constant offset in R1. So you put offset to R1 and you ignore. Right now we don't care about R2, so just know about this LDC, and with LDC we will do those instructions. So let's go to our sample. So you see in here this is the way we read this is the way we read from user. So it says read an integer from stdin and place result in R1, ignore R2 and R3. So this is our register. By the way, I didn't mention in the previous video, in here we have 7 registers. Even we can show the registers, how many registers we have. We have 7 registers, but the 7th register is called also PC, and you are not using that one. So sample.tm. So I say h. So in here I think we could actually print enter a command. Okay, let me first run it. Okay, R, yes. So you see in here 0 1 2 3 4 5 6 7, so all of them are 0 right now. As you see in the row 1 R says print the content of register. So we have 7 registers, as I said, and the content is all of them are 0. And I am going to say go, run it, and I say 10. So you see it run and number of instruction executed. Okay, the result was 100. So I am going to say R again. So you see in the 0 it is 100 and 1 is 10, and the rest didn't change, but this was number of instruction executed, probably 5, and probably it write this one. This is the PC that you don't write anything in here. Okay, and let's look at here what we do. In here, that's what we are doing. We simply get input, we put this in the register 1, and then we LDC, we get this value, we give this value to register 1. In here you see register, it was 1, so we did by this one, and we multiply 0 register with 1 register, and we save in the 0 register. So when you multiply them, it became 100. So as you see, it's in here it is 100. We multiply this register, that is 1, with this one, which is 0. So what was our output input in 0? It was 10. So when you multiply and you write it here again, so it is 10 now. And when you say out, you write this, but we generally always you have to write these two. When you don't write it doesn't error, but that is much better you write it. So like what the difference is, like when I say okay, it is already a halt, but I didn't use it, probably it did automatically. So I'm going to run again halted. So instead of saying that, it says halted, but okay, let's continue and then do it again and make sure that we save the file. Go and 10. So I enter 10 and it says halted. So the difference is this one, but you have to you should put this one. This the way we write the content of this one, the first register, and then this is the R1. If you look at in here, you write the content of R1, which is this one, and then you ignore those both, and that's it. So this is the way we write. So we learned about and out. So let's about addition, let's do the addition. So let's do the addition. I am coming here, I am going to simply put add in here, and I have my output, and I am going to simply multiply them. So what will be the result right now? Let's try this. Say quit, and then run this code tm exec sample.tm, and go, and then enter a number which is 10. So at this time it is 20 because okay, let's say R2. So because I entered 10 and I said I first register is 1, and just simply add this, so it became 10, and number of executions 5, still it is 5. Okay, and that's it. So this was addition. So in addition, you multiply those both. And also what else? For subtraction, you need to write sub in here, and after you write sub in here, the important thing is here this, you from R3 content of R2. So from here you will remove this one, from here this one. So from register 1 I will remove register 0, and I will print this in register 0. That's what I do right now. But as you see, I give 10 in here. Let me give like 100. Okay, 100 in here. Now LDC register, you don't have to do that actually. For the minus numbers it works. Okay, even let's give 5. It doesn't matter what number you give. So I am going to, from these I will remove I will subtract 0, whatever I simply insert. So I am going to write the code tm exec sample tm. By the way, I am just clicking up button to write the code that I write in the first time, so it saves the time, and I am simply saying okay, run it, simulate it. So, and then I am going to say let's see registers first. So you see all registers are 0, and I am going to say okay, go, and I say I will enter 20. For x I am entering 20, so my instruction this 0 becomes 20, and when I say 20, what happens? It says 15, because I have put 5 to register 1, and then from register 1 I simply subtract okay, it is 15, that's true, but doesn't it work for minus numbers? Okay, in the documentation it was written like this even. Okay, go, and I am writing 20, I get 25. So what it means? So I think there is something written wrong in here, or it is simply like this. Okay, so how about I say that I will enter a minus number also. No, this will be positive, and I am going to enter minus number. So the documentation, okay, I am going to, it's 5, I am going to enter 15. Okay, no, go, enter minus 15 and minus 20. So from this actually we cannot understand that it works or not. So like it's 5 when simply I say quit and run this code again, go, and I enter 20, the result is 15. So it means from the register 1 I am subtracting register 1. From here I am just removing this one. But what if I change their place? Okay, let's change like this, and then say quit, and then run again. So I'm saying go, and then value for instruction. So I'm going to end at 20 again, like minus 25. Okay, even in the documentation it was written like this, but subtract content of R3 from content of R2. Okay, okay, that's true. So I think like content of R3 from content of R3. Okay, that's true. That's true. I confused. It is like I confused. You just simply content of 2 minus 3. Okay, I confused that one. So it is still from this order, and I was thinking like why it would be in the opposite direction. Okay, so this from the second register you simply subtract this one. Okay, you say okay, that's why we say 0 1. If we don't, if we change like from here the second one, we remove this one. Okay, so and this was subtraction, and multiplication we already done multiplication. Division, so I am going to simply say division in here, and so I'm simply saying division in here, and then I say division in here, and I multiply 110. So division, okay, this is not necessary because it was for the first example, but rest of the example is not necessary. So division, how to do division? Divide content of R2 by content of R3 and place result in R1. So that is the way we do. You will divide content of this one with this, and then you will replace these two in here. Whatever register you write in here. Generally in here I'm using register 0, but you can use other registers. 1 to 6 register you can use. 0 to 6 registers you can use. Okay, and so I am going to divide this by what? I am going to divide this by 5. And let's do it. So I'm going to say quit, I'm going to say run, and I'm going to give 20 in here again. Okay, go, I'm going to give it 20, so it became 2. Yeah, okay, it is 2. So I'm going to say R again. So you see still I am using the first two registers. I didn't use the rest of them, but I can use. If you need, you can use them. And this was multiplication, and I already showed you halt. So multiplication, division, addition, and all of them are. This was the easy one actually, and it is done in this way. And that is it. Let's end this video. For the next video, I will be talking about this LDA and equals, not equal, greater than, and about this. So let's finish this video in here.